In this video, I'm going to show you some challenging mole calculation. And the first case here is about determining empirical formula and molecular formula of organic compounds from combustion reactions. So let's take a look at the example. Compound Z contains only carbon, hydrogen, and oxygen, burns completely in air to form carbon dioxide and water as the only products. 2.43 grams of Z gave 3.96 grams of carbon dioxide and 1.35 grams of water. And hence, you are required to determine the empirical formula of Z, and by providing the relative molecular mass, which is 162, you can determine the molecular formula of Z. So in this question, based on the information, you can somehow generate all these in your mind. First of all, the empirical formula of compound Z do actually have carbon, hydrogen, and oxygen, but you don't know the ratio, and that's why there's something you need to find it. And when compound Z is burnt, react with water, it will produce carbon dioxide and water. React with oxygen and will produce carbon dioxide and water. And you can somehow generate this kind of chemical equation, though it's not balanced. But based on the empirical formula, it also suggests the simplest whole number ratio between carbon, hydrogen, and oxygen, which is somehow equal to the mole ratio between carbon, hydrogen, and oxygen. So by determining the mass of each element and hence the number of mole of each element, the mole ratio can be determined. So based on the conservation of mass, that the mass of each element before and after the reaction remain unchanged. So when you take a look here, the mass of carbon in carbon dioxide is equal to the mass of carbon in compound Z. The mass of hydrogen in water is the mass of hydrogen in compound Z. And the mass of oxygen in water is equal to the mass of oxygen in compound Z. Wait. There should be a problem, right? The mass of oxygen in water is equal to the mass of oxygen in compound Z. I'll give you some time to figure out the problem here. So in this reaction, why is it necessary to write a chemical equation? Although it's not balanced, you can see that the reactants, there's compound Z and also oxygen gas, both supplying oxygen atom. And in the product side, there's carbon dioxide and water, and you'll find that there's also oxygen there. So if you try to draw this conclusion and saying that mass of oxygen in water is equal to the mass of oxygen in compound Z, is not really valid, because the mass of oxygen in water, some may be due to the mass of oxygen in the oxygen gas. How do we know that whether there's mass of oxygen coming from which side? And hence, there's also another way of calculation, is that if you know the mass of compound Z, in this case is 2.43 grams of compound Z, minus the mass of carbon in compound Z, and also the mass of hydrogen in compound Z, then you can determine it. And hence, you can avoid finding what exactly the mass of oxygen in compound Z. Okay? So let's take a look for the data. You can find, based on the number here, for the mass of the carbon in compound Z is actually, by considering the carbon dioxide, that actually is the percentage by mass, the fraction here, for 3.96 grams of carbon dioxide, and actually there's certain percentage of percentage by mass in carbon, and hence you can find the mass of carbon in it. And similarly, for the mass of hydrogen, you just find the mass of the water and then find the fraction of hydrogen in the water molecules, and then you can determine it. And eventually, you can also find the mass of Z and use the mass of Z minus the mass of carbon in Z and minus the mass of hydrogen in Z. You can determine the mass of oxygen. So this is actually applying the mole series, the skills for 1, 2, 3, which is about how do you convert mole to mass, mole to number, and last but not least, how do you convert mass to number. So it's very important, recall. And after you got the mass of each element, then things can be settled very easily because you can quickly draw this table. And in this table, you can see that the mass will be like this, and you can find the number of mole of that and find the mole ratio. And I would like to draw your attention to how can you convert the mole ratio. Is that you can find 0.09 and 0.15 and 0.075, and then you have to define the smallest number to find the whole number ratio. And after that, you find something like this. You define it, and you get 1 to 2, 2 and 1, and eventually you try to make it to the whole number. So you can just check your calculator that 1.2, and then you can somehow join a fraction, and then you can make it in your calculator. And eventually you can find the empirical formula of Z is C6H10O5. And this also applies the skills in Mode Series 6 about calculation involving empirical formula. And with the empirical formula, you can let the molecular formula be something like this, where N is the whole number. And you can substitute the number for the relative atomic mass for this element in the compound Z, and also to substitute the number of the relative molecular mass, and to determine the value of N. And after determination, you can find the molecular formula. So for the molecular formula, in this case, is equal to the empirical formula. Okay, and this also applies the skills for Mode Series 6. So here's technically how do you find the empirical formula and molecular formula through a combustion reaction of the organic compounds. And last but not least, there's a practice, and this practice is a correction, so changing the number of the compound Z, and then it's just change the number of the carbon dioxide and water's mass. And here's the answer profile. We strongly recommend to take a piece of paper and then try to do it. If you have any questions, leave me a message, and also rewatch the first part of the video to see whether you can transfer your knowledge to this part. So if you have any question, make sure you leave me a message in the YouTube or in somewhere. Okay, let me know. See you guys.